Okay, in these problems for 4.1 and 4.2, you'll almost end up doing two problems in one. In 4.1, they have you find the standard divisor and the standard quotas. When you get to 4.2, if you've already done 4.1, it will just take you back to the same problems and have you finish them under Hamilton's method. So once you do have standard quota and standard divisor, figure out the number of seats or representatives or buses or whatever they're talking about. Just finish the problem is what 4.2 asks you to do. So here we'll just do these two together. Okay, so in this one, they want the standard divisor. So the standard divisor is always our total population divided by the number of seats or representatives or whatever it is that we're handing out here. So here our total population looks like it's the average number of patients. So that makes sense. They're trying to figure out if you have more patients, your shift should get more nurses. So how many nurses or representative seats do we have to give away here? So we're trying to figure out how can we apportion these 225 nurses fairly between all the shifts. So first thing we have to do is figure out, well, what is the total average number of patients? So it looks like if I add up these four numbers, it gives me 2,700 patients on average per day that are split up between four shifts. So my standard divisor is 2,700 divided by 225. Which gives me 12. All right, picture what the meaning of the standard divisor is here. It's saying it takes 12 patients on average per shift to get one nurse, right? Because this is 12 over 1, so the total population, the number of patients divided by nurses is on average. If you have 12 patients, that should get you one nurse for your shift if we're spreading them out fairly. Okay, and that's part B, I guess, explain what the standard divisor means. You might want to write that out in words for your part B. I'll just describe it so I don't run out of space on the screen. Okay, then part C, find the standard quotas. So we're saying if it takes 12 patients to get a nurse, so this one is 871 patients on average. If it takes 12 to get a nurse, then what we care about is how many groups of 12 do all these shifts actually have? So how many times does 12 go into all of these numbers? So to find standard quotas, I take my number of patients and I divide by the standard divisor. So I want to, for every single one of these numbers, divide by 12, since that was my standard divisor. That will give me my standard quota for each one. So first up, 871 divided by 12 is 72.583 repeating. And you might want to be careful not to round too much, because remember what we're going to do in Hamilton's method is actually divide or see who has the most residual or what decimal is the closest to rounding up. So if you round them too much, you lose some accuracy, and sometimes it's hard to tell who would be the closest to rounding up. So for B, 1029 divided by 12 is 85.75. And then C is 610 divided by 12 is 50.83 repeating. And then last one, 190 divided by 12 is 15.83 repeating. A big check is if we did this right, this should add up to 225 nurses exactly. But then where's the problem in this? Well, I can't give a shift 0.75 of a nurse. I have to give them one whole nurse or not. And so for part 14 here, they want us to finish the problem. So how does Hamilton's method work? Well, first we round everybody down. And so A, B, C, D, shift A is going to get at least 72 nurses because that's the biggest whole number that they made it to. Shift B is going to get at least 85 nurses. Shift C is going to get at least 50, and Shift D is going to get at least 15. So that adds up to a total of, let's see, 10, 12, carry the 1, 6, 14, plus 8 is 24. So 242. or 222, sorry. 6, 14, oh yeah, 14 plus 8. Run out of space there. Okay, so I want to add that up. Why? Well, I just gave away 222 nurses, but I actually have 225 to give away. So what Hamilton's method is doing is deciding, what do I do with the 3 extra? So who should get the extra nurses? We'll come over here and say who was the closest to getting an extra nurse to begin with. So if I look at their decimals, 0.83 and the other 0.83 repeating, they were kind of tied for first on rounding up. And then the next one, 0.75, is bigger than 0.58, so they're second or third for rounding up if these two are tied for a second. All right, so I only have 3 extra ones. These were the 3 closest to rounding up because their decimal was bigger than 0.58. So that means they get an extra nurse, they get an extra nurse, and they get an extra nurse. We hand them out in order of who was the closest to rounding up. So our final answer for our apportionment is A gets 72 nurses, B ends up with 86 because they get an extra 1, C ends up with 51 because they get an extra 1, and D ends up with 16. And then it's also a very, very good idea at the end of this, since your goal was to hand out 225 nurses proportionally to all the shifts, at the end make sure that 72 plus 86 plus 51 plus 16, make sure that actually adds to 225. And it looks like it did. So we successfully handed out all of our nurses proportionally to each shift using Hamilton's method.